Okay, so now we are going to do some examples. I'm going to do example 25.6, 25.7 and 25.8, and then I'll also do some problems, alright? So here we are going to learn how to find the location of the image, size of the image, and also orientation of the image, and then also magnification of the lens, etc. Right? So it's not difficult. For lenses, there are only two formulas that you have to remember. One is 1 by f, where f is the focal length. 1 by f is equal to 1 by d sub o, that's for object, the distance of the object from the lens, plus 1 by d sub I, that's the distance of the image from the lens. Then the magnification n is equal to HI, the height of the image, divided by HO, that's height of the object. Of course that makes sense because magnification means you want to know how big the image is compared to the object. And then we have negative di, distance of the image from the object, from the lens, divided by distance of the object, that is the object distance from the lens, alright? So I'll explain to you about this negative sign later. So the first example that we want to do is example 25.6. Here you are giving a converging lens or convex lens, and the distance and the focal length of the lens is 0.5 meters. So little f is equal to 0.5 meters. There's a converging lens. And then a light bulb is put at 0.75 meters away from the lens. So that's an object. So we call it DO is equal to 0.75 meters. Alright? So you put the light bulb 0.75 meters away from the lens, and then you want to know A, location of the image, so that you want to find DI, and B, you want to find magnification, that is N. Right? So first of all, what you need to do is you need to draw a picture, because that always helps. So I'm going to draw lens here. So this is focal length f, which is equal to 0.5. I'll do it here. F is equal to 0.5 meters. So from here to here is 0.5. So 2f will be about here. That's about 1. Okay. So I'm going to draw light rays through this, so it might get erased, alright? Now this is 0.5, so approximately this is 0.5. So this is about 1 here on this side. And you are going to put the object at 0.75 meters from the lens. So 0.75 is between here. So I'll draw here. That's your object, that's the light bulb. And then I have to draw a picture to get the image. So in order to do that, I'm going to draw parallel light rays, and then going through this focal point, and then another one going through the center of the lens. So they actually do meet at this point, and that's where the image is going to be formed. And although I don't draw it exactly to scale, you will see that from our previous diagrams, we know that if the object is between f and 2f, then the image will appear beyond 2f, right? So at least that part is correct, and the object will be upside down, the image will be upside down because it's a real image, because the light rays do really beat here, and it's upside down, so it's a real image, and it's larger than the object. All right? Okay? So at least we know what we should expect. So just don't blindly put numbers in your formula, because if you make a mistake, then you will not know. If you check with the diagram, then you can tell whether your numbers are correct or not. So now let's find the distance of the image. So 1 by f is equal to 1 by d sub o plus 1 by d sub I. Since we want 1 by d sub I, it will be 1 by f minus 1 by d sub o. 1 by d sub I is equal to 1 by f is 1 by 0.5, because focal length is 0.5, minus 1 by d sub o, that's the object distance, which is 0.75. So 1 by d sub I is, I can do a common denominator here. I think it's 1.5. 0.5 goes into 1.5 3 times, minus 0.75 goes into 1.5 2 times. So that's 1 by 1.5. Right? I'm sure you can use your calculator to get the same answer, but I don't really like using calculators, as you know. So di is 1.5 meters. So obviously it's beyond 2f, and actually even on, although it's not to scale, looks like it's about 1.5 meters, right? Now what about the magnification? Well, so that's the answer for part A. For part B, the magnification M is equal to, the formula is HI by HO. We are not given any information about the height of the object, so we don't know how to use this one, because we will not get anything. But we know these, so we can use this part. So minus di by do, which is equal to negative di is 1.5 and do is 0.75. So the answer is negative 2. So magnification is negative 2. What does that mean? The image size will be twice as big as the object. And it's upside down. That's what it tells. The negative sign tells you that it is opposite to the orientation to the object. Right? Okay. Now, let's do problem example number 25.7. So let's do 25.7. So these problems are not difficult. So if you go through this video and then practice a couple of problems, then you'll be all set, right? So let's do problem example 25.7. So it says a book page is held at 7.5 centimeters from a convex converging lens, and focal length is 10 centimeters. So let's do that. So that's the lens. Focal length is 10 centimeters. So that's your F. And a book is held at 7.5 centimeters. So it's somewhere here. Okay, so let's make it a little smaller. So now we know that the first ray will come in parallel to the axis, and then it will go through the focal point. And this is at 7.5 centimeters. And then it will go through the center. It will go back. It looks like they are coming from here. So that's your virtual image. And you put your eyes here so you can see this. Right? So you can see these light rays looks like they come from here. So that's your virtual image. So here, what you want to find is you want to find the distance of the image and the magnification, right? You want to find the distance of the image and magnification. So the distance of the image means this. Distance of the object is this 7.5 centimeter from here to here, right? Okay, this is the focal length, so that's 10 centimeters. So the formula is 1 by F is equal to 1 by T sub O plus 1 by T sub I. We know D sub O is 7.5 centimeters. D sub I is the one that we want to know. F is equal to 10 centimeters. So we know everything. So we want to find D sub I. So 1 by D sub I is equal to 1 by F minus 1 by D sub O. So 1 by F is 1 by 10 minus 1 by 7.5. Right? So and I can find the common denominator here. So let's make it, I'll make it easy for you. Let's make it 750. So 10 go to 775 times minus 7.5 goes into there 100 times. So the answer is negative 25 by 750 or negative 1 by 30. That's 1 by D sub I. So D sub I is equal to negative 30 centimeters. So now this time we are getting a negative sign for D sub I. What it means is that the image is formed on the same side as the object, not like other the 25.6. It doesn't appear on this side of the lens, but it's appear on the same side as the object. That's why you get a negative sign for D sub I. Alright, so we get D sub I. So once you get the image distance, now the next thing we want to do is the magnification. M is equal to negative D sub I by D sub O. which is negative. This is negative 30 centimeters. And d sub O is 7.5. Now in the book, they're wrong, that instead of 7.5, they are using 10 here, right? Book is 10 centimeter. But 10 centimeter is the focal length, so the book is wrong, all right? So that's equation 25.38. Equation number 25.38. They didn't check it carefully. All right, but anyway, so you get 4. Negative is positive, so you get positive 4. That's for magnification. So now what does it mean? This time, positive magnification, so that's the same orientation as the object, and it is 4 times, it will be 4 times bigger than the size of the original object. Alright? Okay? So now we clear about the sides. Now let's do another example, 25.8. Example 25.8. I'm doing 3 problems in this video. I hope it's not too long for you. So for 25.8, it's a diverging lens again. Oh no, this is diverging lens, so that's a concave lens, so it's a different one. 25.8, so that is diverging lens. Focal length is given negative 10 centimeters. So I'll explain to you in a second. And the object is given at 7.5 centimeters. So things are the same as before, but the only thing is converging lens and diverging lens. You want to find DI, image distance, and then you also want to find the magnification M, right? So here, remember when we were drawing pictures about diverging lens, this is F here and this is F here. So, doesn't matter when you put this object, here in this case this is negative 10 because remember parallel rays here will who are diverging looks at as though they are coming from this point. So that's why, so now the incident light rays are coming from that side and the focal point you use is on this side, and so that's why this one is you use F is equal to negative 10 centimeters. Alright? Okay? So for diverging lens, then you can always say that F is equal to negative, right? Some negative number. So that's just to remind you. So now let me draw the actual picture for this problem. So this is focal length is 10, distance is 7.5, so it's inside the focal length. So let me draw here. The lens is big. So F, this is negative 10 centimeters here. And so this 7.5, so somewhere here. So light ray going parallel, go out diverging. Looks like it's coming from here. And another one will go through the center of the lens. And then the virtual image is going to form at this point. So that little short one is your virtual image. Let me draw it in red. So that's your virtual image. So obviously the object is put at 7.5, so this is at, so let me, don't use the negative sign here so you will not confuse. Right, so the length is from here to here is 10 centimeters, but in the formula we have to use f is equal to negative 10 centimeters, right? And this is 7.5, so then the answer di, the image distance from the lens, will be less than 7.5, right? So that's what I want you to realize. So before you do anything, you will know where the image is going to appear, right? So you will not make mistake. All right. So let's start with di. 1 by f is equal to 1 by d0 plus 1 by di. So 1 by di is equal to 1 by f minus 1 by do. And 1 by di, f is negative, so that's negative 1 by 10 minus 1 by do, which is 7.5. Right? So this time they will add up. So I'll get a negative sign. Well, I don't want to confuse it. Let me write step by step. So this will be 750. So that's negative 75, negative 100. So that's negative 175 by 750. So di is, I have to flip it, 750 by 175 meters. And that is, from the book, that is 4.29. So that is negative 4.29 meters. So you see, as we predicted, the image distance has to be less than 7.5, and it is. Alright, so now let's find the magnification in m is equal to minus di by do. So minus, di is minus 4.29, and do is 7.5. And negative is positive. M is equal to 0.571. 0.571. So now you see magnification is positive. That means the orientation of the image is the same as the object. So the image appears upright, right? So that's a magnification. And then we see that from the figure, it is shorter than the object, so this is magnification is less than 1, right? Okay, so I think I'm going to quit here.